All right, all right, all right. Let's take a look at infinite limits at infinity. If a limit rises without bound, it's going up, up, and away. The limit is going to be infinity. And if it decreases without bound, it's going to negative infinity. This still holds true as x goes to plus or minus infinity. I did a limit as x approaches a here, but the same holds true if we're doing infinity, okay? So like we had earlier, limit as x goes to infinity of x cubed is positive infinity, and limit as x goes to negative infinity is negative infinity. So how do we know what's going on where? There's a general rule of thumb depending on how it works. The reason why all of this holds true is based on, it's called the delta epsilon proof, and it's in 4.6 getting ready. But we care more about really what's going on at the ends there. So this is like the end behavior on a graph. And we had some pretty pics of this in 4.5 getting ready, which I won't show again. But what it boils down to, we have x to the n. If n is even, it doesn't matter if I'm approaching positive infinity or negative infinity, the end result is infinity. Okay? If n is odd, like let's say this is like x squared, x to the 4th, x to the 12th, stuff like that. Same holds true for when n is odd. If x goes to infinity, we're still going to positive infinity. But when x goes to a negative value, a negative infinity, this changes signs. And this is related to like x cubed, well, shit, even x to the 5th, x to the 11th, stuff like that. And I think the easiest way to see it why is x cubed is x times x times x. We would have 3 negatives there, and the sign cancels out, and we have just a negative sign left. Even amounts of negative signs cancel out. So we can take advantage of this stuff. Let's find the limit as x goes to infinity and negative infinity of f of x. Let's say f of x equals 3x to the 4th power. So doing limit as x goes to infinity, remember how limits work? We can actually pull the coefficient out. It's not necessary, but I wanted to do it just to remind you. And so 4 is an even power. The exponent is even, where no matter what happens, the limit is going to positive infinity. We're multiplying by 3. That doesn't really change it. It's still an infinite. We're just going to infinity faster, so it's infinity. And the same holds true if we stick in negative infinity. So we're going to get infinity either way. But how does this change if f of x is now negative? If we do negative 3x to the 4th, this looks weird. I'm going to fix that. Put that down a little bit there. There we go. That's bothering me a little bit. If we do negative 3x to the 4, we factor out the negative. And this part is still infinity, but now we've got a negative multiplier on it. It's going to negative infinity now. So the coefficient affects the outcome. The coefficient affects the outcome, or the sign of the coefficient, really, not so much like the value, unless it's 0. 0 will fuck everything up, but then you wouldn't even be talking about it if it's 0. So the sign of the coefficient will affect the outcome. Why don't you go ahead and give it a try on these two? F of x equals 2x to the 5th. F of x equals negative 4x cubed. And then I'll move the video up or screen up in a second. All right, on 2x to the 5th, I didn't do it. I'm going to do it live. That's another way of doing it. It was sneaky. So we're doing limit as x goes to infinity of 2x to the 5th. 5 is an odd power, 2 is positive. So the odd power goes to positive infinity there. And for negative infinity, it's a positive times negative infinity. I didn't write negative infinity. So it didn't change. It's still negative infinity. If I do that here, limit as x goes to infinity of negative 4x cubed. This is like negative 4 times infinity, which is going to give us a negative infinity. So even though that's normally a positive infinity, the negative 4 is messing it up. If we do limit as x goes to negative infinity, negative 4x cubed, we got the negative 4 times negative infinity. And the negatives cancel, and we're back to a positive infinity. All right. That's a relatively short video because the next section is long. We're going to look at end behavior for rational functions.